Okay, functions. The very first unit in September. Okay, so functions. The only stuff you really need to know for functions for the final exam, well, it's two things really. Fogg and Goff. So composite functions. That's the open circle is a composite function. What does it mean? Yeah. Which one are you talking about? Top one or the bottom? Okay, nice save. So you basically work this way, and that goes into there. So this is f of g of x. So function g is being put into function f. And then the second one, it is function f is being put into function g. So if I say, we'll make this easy, 3x plus 1, and g of x is x squared plus 1. We're going to do both. So g of x is x squared plus 1. So this is f of x squared plus 1. What is it? Whatever's in brackets goes where? In for the x's. So this whole thing goes in for this x right here. So it becomes 3 x squared plus 1 plus 1. So I get 3x squared plus 3. So 3x squared plus 4 is your answer. That ringing some bells? All right. Goth is the reverse. It's g of f of x. So f of x is going into g. So instead of x squared, I get 3x plus 1 all squared, which makes this slightly more annoying. Because why? Yes, you have to FOIL. 3x plus 1 all squared is not 9x squared plus 1. It is 3x plus 1 times 3x plus 1. So then you FOIL it out. 9x squared. 6x plus 1 plus 1. There you go. 9x squared plus 6x plus 2. I will expect you, I'll give you one. So I'm going to make it a short answer question worth a couple marks. So I will ask you to do something like that. Okay? The only other thing from the first chapter is, and we touched on it briefly, but it came back in transformations, is if I have f to the minus 1 of x. What is that? Sorry? It's the inverse. So this is the inverse. It does not equal 1 over f of x, right? Those are not the same thing. 1 over f of x is a reciprocal transformation. F to the minus 1 is the inverse. And the inverse just means switch x, y values. That's it. It's also a reflection. Just this ties into transformations. I'll do that in a sec here. A reflection over the line y is equal to x. Remember that? So if you had the graph of a parabola and I ask you to do the inverse, the y equals x line is like that. So the new graph looks like f to the minus 1 of x and green one is f of x. So you switch the x, y values and you reflect it over the line. You will be asked to sketch an inverse. Oh, how do you generate the equation of an inverse? Yeah, so if I have f of x is equal to, come on, let's go on here, x squared plus 1, and I say find f to the minus 1. Switch your x and y. F of x is the same as y, so we're going to say x is equal to y squared plus 1. Then what do? Subtract 1. X minus 1 is equal to y squared, and then you square root it, so y is equal to root x minus 1, right? Plus or minus. Don't forget the plus or minus. If you're introducing a square root, you have to account for the negative. You can check your answers afterwards and see if one of them doesn't make sense. You can throw it out, but you need to account for it. Okay, that's functions. We feel comfortable with function. Oh, one more thing. Shane. It's 1 or x or 0. Just one of those? Somebody said it. If you put the inverse into the original or you put the original into the inverse, it's always x. I don't think so, but that's just adding the functions together. Okay. Unit 1 complete. 10 minutes, 9 minutes. All right. Transformations. Okay. What's the big equation for transformations? Ooh. All right, there we go. Y is equal to AF BX minus H plus K. That's pretty much all of transformations. Okay, so move on. Done. Exactly. It allows you to sketch a whole bunch of different graphs. Okay, we'll go through them. A, what does A do? By A. What does B do? Horizontal stretch by, sorry, what? 1 over B. Do you remember what it's called? Horizontal translation. Translations are when you're adding or subtracting, stretches or when you're multiplying or dividing. I'll just say HT, horizontal translation, which means left or right, by H, if h is positive, okay, so if h is positive, this is the tricky part. Which way do you go? If h is positive, you go right. So look at the formula. It's minus h. So if you have f of x minus 2, what's your h value there? H is positive 2, which means you go to the right. Okay, it's whatever makes it 0. Okay, so if it's positive, you go right. If it's negative, you go left. The negative one looks like this. If I say f of x plus 2, your h value is negative 2. So you're going left. Okay. And then k is vertical translation, which is just up, down. If it's positive, you go up. If k is greater than 0, equals up. If k is less than 0, you go down. The only trick is h value and the b value, because the factor you change it by is 1 over b. That would be a trig question, because it has to be sinusoidal, like repeating. What if a and b are negative? A less than 0. What does that mean? Flip or reflection over x-axis, because you're changing the y values, so they change up and down. So it flips over the x, and again, if a or if b is less than 0, it's a flip over the y-axis. Okay. Order of operations. What goes first? A, B's. Those are the stretches. And the flips with it, because you just use the negative, right? You just multiply by the -2 or the -1/2 or whatever it is. So stretches, flips. I'll put stretches, flips. Then what? I can't hear you. H and K. So the translations, H and K. Translations, those are H, K. What always goes last? Your name. Sorry? Do we remember what goes last all the time? Starts with an R. Rational and radius is what I heard. They do start with R's. Not reflections. Not a rotation. They create asymptotes. Yeah, you're close. Restrictions, reciprocals. The 1/overs. Remember doing those graphs? No. Reciprocal goes last all the time. But no, remember, if you're doing a reciprocal graph, well, here, I'll do one quickly. If I have, we'll do a polynomial. Here's my graph, f of x. And you're going to do a reciprocal transformation, which is 1 over f of x. I'm going to have to label these A, B, C. what happens when you do a reciprocal transformation? What happens at the x-intercepts? You get asymptotes at the x-intercepts, right? Because they have a y value of 0. It's 1 over that value. So they A, B. We did this, right? It's just like September we did it. And then this part of the graph is below, so it'll stay below. And remember I told you your horizontal asymptote's always 0 until we change the rules. And we changed the rules like at the beginning of this month. So when you're doing these, it's still 0. Okay?
So everything at 1 stays or something.
Yeah, plus or minus 1 are the... So you get this bit. If you're between, you get this stuff. Below, you get this stuff, and then above. Remember that?
What about the other one when something like they made every negative value?
That's absolute value.
Oh,
I'm not going to put one of those on the test.
you're not amazing.
Now I'm trying to remember. I'll check. You can, but it's not factorable. It means that's not a factor. You have to have a remainder of 0. Okay, there's order of ops. Look, I'm going to ask you general questions, right? I'm not going to ask you the nitty-gritty stuff for transformations, although you should know that how to move a point. We did this on Friday quickly. You don't get a formula. Well, you get the pink formula sheet, but this formula is not on it. And I will ask you to move a point. You don't have to remember these formulas. You can just understand what changes x values and y values. So let's do the y's first. If I have the point, I'll just call it xy for now. Which values in this equation affect your y values? A and k. Which one do you have to do first? A. Do you have to flip A? No. So you just go A times your y value, and then add the k. That's where the formula comes from. And then if you're doing your x value, what variables affect the x? B and h. What do you have to remember about b? It's 1 over b. So it's 1 over b times your x, and then you just add on your h value. That's how you move a point. Okay. We okay? Plus h. But you have to determine what the h value is, right? That goes back to this stuff right here. Yeah. Okay. Transformations, done. Look at 10 minutes for transformations. Now everybody's favorite unit. Look at the whole tone of the class just went longs. You like it? That's good. All right, logarithms.
Okay, I'm ready to rumble, dude. Do you want this?
No, you can use it.
Okay.
Logarithms. Okay. Now, you get your pink sheet. Your pink sheet has the log rules on it, but I'm going to summarize them here. Okay. Logs. Here we go. If you're multiplying, what are you doing to the arguments? Adding. So this is log m plus, oh, wow, I messed it up. log m plus log n. If you're dividing, you are subtracting. If you have an exponent sitting up there, what can you do with that? You can drop it down in front. This, I don't know if this one's on your sheet, so you should remember it. If the bases match, the base of the log and the base of the argument match, what is the value? Just whatever the exponent is, so it just equals x. If you have log as an exponent, so base b to the exponent log base b of x, the base and the base match, therefore it's just x. And then if you try to log the number 1, no matter what the base is, you get 0. Those are the log rules. And they're on your sheet. I don't know. I don't think these ones are on your sheet. Are they? No. Okay, so you need to remember those. We'll do the log graphs, and then we'll solve a couple of equations, and then we're done. So the log graphs. Log and exponential, right? We'll do exponential first. So y is equal to b to the x. Those are exponential growth curves. The orange one, is the base positive or negative in the orange one? That's a positive base. B is greater than 0. Oh, no, it's not greater than 0. Can the base be 0? No. Can it be 1? No, it has to be bigger than 1. Because if it was 1, then it's just 1 to any power is just 1. So the base is bigger than 1 equals a growth. That's the orange one. If the base is less than 1 but bigger than 0, because your base can't be negative for an exponential function, it is a decay curve. Do we remember those? Do you remember that the logarithmic curves are inverses of the exponential curve? Where's the horizontal asymptote on a exponential? 0, right? That is it. How do you move that up and down? The k value. Yes, the k will move it up and down. Whatever k is. So if I said y is equal to 2 to the power of x plus 2, what's the horizontal asymptote of that graph? 2. Okay, whatever k is moves the horizontal asymptote up and down. So then the log graphs are inverses. So instead of having a horizontal asymptote, we now have a vertical asymptote, which starts at 0. Two types. You can have, so this is a log base b of x, y, and this is a b value that is bigger than 1. So yeah, I should have drawn it in orange because that would make more sense because it's the inverse of the growth over there. Actually, I'm going to draw it in orange just so it matches. It's the inverse of the growth curve here. And then the pink one is the inverse of the decay curve, which means it's a logarithmic decay. So it looks like that. So that's log base b of x equals to y, but b is between 0, 1, and 0, like that. So it's a fraction, proper fraction. And what determines the vertical asymptote of a log graph? H. So if you had y is equal to log of x minus 5, what's your domain? X has to be bigger than 5, right? Because you have a vertical asymptote at 5. All right. So what I'm really going to ask you with logs is simplifying things and solving log equations. So let's do some practice with that. So this is a simple one. If no base is written, what base is it? 10. Okay, so what do I do with the first one here? Yeah. So I can rewrite the 100 as 10 squared. As soon as you see log 1, what do? It's gone, 0. Thanks for coming. Thank you. And the last one here, I changed the 16 to squared. So that is, I just created one that has an answer of 0. I didn't even mean to do that. So 10, log base 10 of 10 squared equals 2. This equals 2. So the answer is 0. And the reason we did it that way and not putting them together is why can't we put them together? They have different bases. Oh, I forgot a log rule, didn't I? Change a base rule. Does anybody remember? Well, I guess it's on your sheet. You remember change a base rule? Yeah. So if you have log base b of a, you can pick any base you want. So I can write log base c of a over log base c again of the base becomes the argument. All right, that's on your sheet. Okay, that was good. All right, so there's a simplifying like that. What if you have something like this? Yes. Your default is to look and ask yourself, can you make them the same base? Because it's way faster instead of logging both sides. Can they be made in the same base? Yes. So that becomes 7 squared. Once the bases are the same, what do you do with the exponents? Or what do you do? I guess you drop the bases and equate the exponents. So you get x plus 2 is equal to 10x. 2 is equal to 9x. So 2 over 9 is equal to x. That's way faster and less chance of making error. Okay? The fun kind, there's two fun ones, are when I go 2 to the x plus 1 is equal to what? 3 to the x plus, I'll just make it the same, x plus 1.
You use examples that you put on the like some questions that are hard.
Is this not hard? Is this not hard?
Like question, like test type questions. Like serious ones. Like the ones that like you're like thinking about solving, not just like the log, quick log rules, like actual log. But there's different ones than like the ones on the test are harder.
Okay, well, how do you solve this then?
Well, I mean, I'm just not in the zone right now. So I'm just asking, like, can you solve it?
That's what I was gonna do.
No, like a really hard one, like a really hard one.
This isn't really hard?
Well, I mean, I don't know.
Okay, well, what do we do?
Like
Can you?
the one that had the pie in it. Do you remember that one? It had like a whole pie. Like, where's pie?
Was it like this?
There was pie in there somewhere.
Most likely it was like that one.
I don't know. Something like that. But it was way more difficult.
Okay.
One of them at the end.
Well, this is a fair exam question because it's not straightforward. Just the numbers are small, but that doesn't mean it's easy. Can I make them the same base? No. So what do you have to do? You got to log both sides. Now you get choices. You can use base 10. You can use any base you want, or you can use my favorite one, which is natural log, and that's what I'm going to do. But you can use any log. It doesn't matter. So I log both sides. Now what? Drop the exponents. Remember to bracket them, because what do you do with the log then? It has to be distributed in, so you get x natural log of 2 plus 1 times natural log of 2 is that. Yeah, we'll do both. Now what do you do? Yeah, you get all the terms with x's on one side and everything that doesn't have an x to the other side. I'm going to move the x's to the left side. And move the natural log of 2 over. So then I factor out an x. And then divide that off. You can leave it like that if I ask for, that's the exact value answer, right? You could clean it up if you really want to. If we're subtracting, that means we are dividing. So that's natural log of 3 over 2 over natural log of 2 over 3. And you leave it like that. But if I ask you to punch it in your calculator, you're going to tell me the answer is? It's -1. Did you use a calculator or did you do it in your head? You can do it in your head, though. It's -1. Be able to get it. If you want to know how you can do it in your head, that's 3 over 2, that's 2 over 3, right? If I flip one of them, so let's say I flip the top one. I'm not going to ask you to do this on a test, but like that. Does everybody understand what I just did? Okay, what is this -1? I can drop that down, right? Then I have natural log of 2 over 3 over natural log of 2 over 3. Anything divided by itself is 1, so the answer is just -1. On the test, it won't work out to be that. It'll probably be a decimal, if there is one of those questions. Okay. The important part is this. Understand how to do this. Okay. Then there are two other types of log questions you need to be aware of. So there are these kind minus so something like that. What do we do here? Not yet. You have to do something first. Yes, you got to put the logs together. Okay? They have to be the same base. We didn't do ones where they're not the same base, so they always will be the same base. If they're not, I probably made a mistake. So you can just put your hand up and ask. But they have to be the same base here. So log 4, I'm subtracting, which means I'm dividing. Then you change to exponential. So the 4 moves over and the 2 becomes the exponent, right? Is equal to 4 squared. And then it's just an algebra problem. X over x plus 1 is equal to 16. X is equal to 16, x plus 16. It looks like there. So I get that. And then you're done, right? You know that I yelled it, so you know that we're not done. You always have to check your answer with logs, right? What numbers are you not allowed to log? Negatives. So don't just blindly be like, it's negative and throw it out. You have to check it. So you take your answer and you check it in. If it fails in one, it fails in all of them. But you have to check both. If I put it in here, can I log that number? Because you're logging a negative, right? So the whole thing blows up. So is there an answer? No. So you'd say ignore, therefore no solution. Just remember that that's important when they're quadratic ones and you have to factor them and you get two answers. Always check both answers because sometimes you throw out one and you keep the other one. Sometimes you keep both, but always check. Okay. Two more types and then we're done. Let's change that from a 4. Let's make it a 7. All right, what do we do? If you have multiple logs, you don't want multiple logs, put them together to form a single log on either side. So I can put these two together. They're being subtracted, so that means they're being divided. Now it's 2. Sorry. See, that's me making a mistake. Sorry, is that why everybody blanked? They have to be the same base, so that's a good catch. Okay. All right, what do I do? Factor the quadratic. Well, multiplies the 1 and adds the 2. Yeah. So it's x plus 1 all squared. That's convenient. Almost like it was planned that way. So what happens to one of the x plus 1s? They will go away. And so then you're left with this. Yeah. So you have a log equaling a log with the same bases. What do we do with the logs? You get rid of them because for them to be equal, it means the arguments have to be equal. So essentially it's just x plus 1 has to equal 7. Therefore, x is equal to 6. And 6, if you check, it works. So, all right. Okay, there's one last one. And it's the kind that look like this. 4 log. I don't know if it's going to work, but. I think that's going to work. Okay. What do you do when you have a log inside of a log? Start in the outside log, and you keep working. This was your bonus question on the Trig 2 test that like just a few people did. So start out there, move it over. I get 4 to the minus 1. What does 4 to the minus 1 actually equal? 1/4. So then you change again, right? So then I get x plus 1 is equal to 16 to the 1/4. What does the power of a quarter mean? 4th root. 4th root, yeah. 4th root of 16 is plus or minus 2. So then you move the 1 over and you go x is equal to 2 minus 1 or negative 2 minus 1, which gives me 1 or negative 3. Now you check your answers, right? So does 1 work? 1 will work because it's 1 plus 1, that's 2. I can log that. Negative 3, if I put negative 3 in there, negative 3 plus 1 is negative 2. You can't log it. So that one's gone. So there's your answer. X is equal to 1. All right. That's logs in a nutshell. Okay.